Welcome to Sigma Notation Practice. And remember, sigma is the Greek letter that looks like the E. So for our do now, we're looking at a geometric sequence, and we want to write an explicit formula to represent it. So the explicit formula is on your reference sheet. And if you look at it for the geometric sequence, it's going to say a sub n is equal to a sub 1 times r to the n minus 1. In this case, our first term is 4. Each time we're multiplying by -2. And I know it's a negative because we're going back and forth between the positive and negative sign for each term. And you just put an n minus 1 up top. For the second one, you want to find the sum of the first 10 terms of the sequence using summation notation. Now, you are able to use your series formula on your reference sheet. If you do forget how to do this, it'll get you half credit, but at least that's a formula you don't have to remember. Because they're specifically saying summation notation, they really want sigma. So for this one, we have sigma. Our starting term is 1 because we're saying the first 10 terms, so we got to begin at 1 up till 10. From there, we have to use the explicit formula that we just came up with. So I'm going to put 4 times -2 and minus 1. And you want to actually find the sum of it, so you have to put it in the calculator. So in the calculator, we have alpha, window, choice 2, summation. I know I used n in the problem, but in your calculator, you have to input x. And you can use x in the problem as well. That's up to you. It's just on the regions you typically see n, so that's really what I work with in general. So we're starting at 1. We're going up to 10. And your formula is 4 times -2. Notice how I put the -2 in parentheses. How it looks on your paper, it should be in your calculator. And then to the x minus 1. And notice how everything is inside these 2 big parentheses, right? There's nothing on the outside of it. That's good. That's going to get you the right answer. And we have that the correct answer is -1,364. And there we go. You can always double check your work using the other series formula to help you out. So just to clarify again, that in order to specify the addition of a sequence or summarize it, we use summation or sigma notation. So the k equals 1 on the bottom is your lower bound, and the n up top is your upper bound. So you're really saying from 1, that's your starting term, and up top is your ending term, what numbers you're adding between. And just remember that a sub k is your explicit formula. So going on to a very recent, I believe this was the January Regions problem. We have that she's cutting wire to construct a mobile. She cuts 100 inches for the first piece, 80 inches for the second piece, 64 inches for the third piece, and we're assuming that this pattern continues. They want you to write an explicit equation for a sub n, the length in inches of the nth piece. So they're telling you explicit formula, which means look at your reference sheet. From there, you have to figure out, is it arithmetic or geometric? And if you look at it, we have 100, 80, and 64, and so on. So the thing is, if it were arithmetic, to get from 100 to 80, you would have to subtract 20. If you take 80 and subtract 20, that's going to get you 60, not 64. So it's definitely not arithmetic. You have to figure out what the common ratio is. In order to do that, work backwards. 80 divided by 100 is 0.8. Make sure you're actually doing it correctly by doing 64 divided by what comes before that, 80, and you'll get 0.8 as well. So this value is your common ratio. From there, now that we know that it's geometric, you're going to take your geometric formula from your reference sheet. We know that our first term was 100. Our common ratio is 0.8 because she's keeping 80% of the previous term, and we have the n minus 1. Now we're saying that she only has 40 feet of wire to use for the project and wants to cut 20 pieces total. And they want to know if she has enough wire. So basically, the 20 pieces is telling you that we're doing the sum of the first 20 terms, right? You need to take all these pieces of wire and you have to add them all up to see if it's less than 40 feet. So really, 20 pieces is your upper bound. Your ending term, however you would like to call it. So in order to do this, we're talking about summation, right? We're adding everything together. You could, if you wanted to, they didn't say how to do this, find the first 20 pieces just by multiplying by 0.8 and then add it all together. It's going to be very long. Or you can use summation notation, right? We're starting at the first piece. We're going up to the 20th piece. And we know that our explicit formula, we already have it, which is why they kind of set you up like this on the regions, is this. Now, you're going to plug that in the calculator, just like we did before, using alpha y equals, I'm sorry, not alpha y equals, alpha window choice 2 summation. And when you do that, you should be getting 494.2353925 inches. So now that you know how many inches she needs, you need to see, does she have enough wire to do this? But you have to read carefully, right? Because they didn't tell you that she has 40 feet of wire. I mean, they didn't tell you, she didn't tell you that she has 40 inches of wire. She told you that she had 40 feet. But our answer is in inches. So if you want, you can convert the inches to feet. You can convert the feet to inches. It's however you really want to do it. Personally, I went from feet to inches. So I was thinking she has 40 feet. Each foot is 12 inches, which means she has 480 inches. But we need 494. So because 494 is greater than 480, no, she doesn't have enough. And we justify it because we showed all this math. Remember, justify means just show your work. You don't have to write a sentence. Explain means write a sentence. You don't have to show the numbers. Also, if you wanted to, you could have used the geometric series formula on your reference sheet if you wanted to do that this way too, because they didn't specify. So you could have used S sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r, if you wanted to. It's up to you. Let's try another example. And we did this example with the summation, not the summation formula, the series formula that I just brought up on the other page in red. We did that in the previous video. Now let's do it with sigma notation. So 2 steps for writing with sigma notation. You need the geometric formula for the explicit form, and then you also need to actually put it in summation notation. So if you look at this, we're multiplying by 1.05 each time. So I know I have a common ratio, and I know that's geometric. So I'm going to start with a sub n equals a sub 1 times r to the n minus 1. From there, my first term is 40. My common ratio is 1.005. And I have n minus 1. So now that we have our explicit formula, you just need to know how many terms are you adding up all together. Now remember, we're going up to 11, but that's the first term, right? So if from here to here is 11 terms, then the entire thing is 12 terms. So we're going from n equals 1 up to 12, right? 12 numbers there, of 40 times 1.005 n minus 1, because that's the explicit formula. They only told you to write it so you don't have to put it in your calculator. And we're all good to go on to the next one. For the next one, we're given a geometric series defined by the recursive formula. They want you to write the equation for the first 5 terms of the series using sigma notation. Now, the problem with this is that they gave you recursive, right? In order to use sigma notation, you need the explicit. So we need to convert first. First up, because we know it's geometric, we want a sub n equals a sub 1 r to the n minus 1. Now, you don't have to remember it, but after this and writing it so many times, you just might. It's telling us our first term right here is 3. And if you look at the pattern, right, we are multiplying by 2, so that's your r. From there, second step is to use sigma notation. We're starting at 1 because it says the first 5 terms, which means you have to start at 1, and we're going up to 5. And then just write this in. And you're done. So let's try another. This one wants you to write an expression, again, not finding the actual value, just writing out the formulas, to represent the sum of the first 8 terms of the series. They want you to use both sigma notation and the formula. This one's on your reference sheet. And they're telling you it's geometric. So automatically this one on the left, find the explicit formula first. My first term is 3. Because I'm alternating between negative and positive terms, I automatically know that I'm going to have a negative common ratio. And it seems like we're multiplying by -4 each time. So when we write this out, we're starting at the first term, and they said the sum of the first 8. So I'm going to put 8 up top. And then write the explicit formula next to it. The other one that's on your reference sheet, S sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. We have the sum of your first 8 terms. My first term is 3. My common ratio is -4. N is 8 because of the 8 terms. And please make sure that in the bottom you are writing parentheses around the negative. If you want, this is correct, but if you really want to, you could have written the denominator as 1 plus 4, right? Because a double negative becomes positive. Let's keep practicing. What you should be doing is pausing your video, seeing if you could do it on your own, and then checking with the video afterwards. See if you're right. Now this one says use sigma notation. So we're using this, and we're writing the formula for the sum of the first 10 terms of the geometric series. My first term is 12,000. My common ratio, it looks to me like we're dividing by 10 each time, right? Because we're losing a 0 each time. So I'm going to make it 1 over 10 to say that I'm dividing by 10. Now, if you're stuck with that, what you could do is on the side, 1,200 divided by 12,000 is 0.1. If you do 120 divided by 1,200, you'll still get 0.1. Now, you can use 0.1 or you can use 1 over 10. The choice is yours. I tend to like fractions, and that's what I stick with. From there, now that you have your explicit formula, step 2, we're talking about sigma notation. We're starting from the first, going up to the top of 10 with this formula. And you're done. We're going to try one more. And I'm going to skip the top of the mixed practice. What I want to focus on is the number 2. So we have Kristen wants to increase her running endurance. According to experts, a gradual mileage increase of 10% per week can reduce the risk of injury. So if Kristen runs 8 miles in week 1, which expression can help her find the total number of miles there's a typo here. This should say she. So which expression can help her find the total number of miles she will have run or she'll have run over the course of her 6-week training program? So the typo aside, going through with this problem, we're talking about the total number of miles that she's going to run, right? So that's how I know that we are adding them together. And that represents sum. So clearly on this side, they gave you sigma notation, and on this side, they gave you the S sub n from your reference sheet. So what I would do is do them both, check your answers. For the sigma notation first, when you go and you find your explicit formula, our first term, she's running 8 miles week 1. That's your A sub 1. Now she's increasing 10% per week because you're increasing, that's a 1 plus R, right? So this is going to be 1 plus 0.10, so 1.10. Keep in mind that this R represents the rate, whereas this R represents the common ratio. This R has to deal with explicit formula. This R has to deal with sequences. I know they're both the same letter and it gets confusing. Anyway, we put a 1.10 down here, or just 1.1 if you want, n minus 1. From there, we're starting at 1. She is running for how long? 6 weeks. So 6 up top with the 8 times 1.10, n minus 1. So this is what our answer should be if we were to use sigma notation. So you can see that this one is missing the n-1. That's no good. This one looks perfect. So we happen to get lucky on the first try. However, if you wanted to do it the other way as well, what we're going to do is use S sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r, also on your reference sheet. We're talking about the sum of the first 6 terms. So our first week she ran 8 miles. Your common ratio is 1.10 and would be 6 over 1 minus the 1.10. So couple things, this one has a variable in it, which is no good because how can you evaluate it if you don't know the value of it? Whereas the other one's still not correct because if you simplify the denominator, 1 minus 1.1 should give you negative 0.1, whereas this is 0.9. So that one's not good either, and that's really why it's choice 1. So keep in mind when you're doing problems with series that be careful if they're asking you to use the formula, which is in the green on the right, or if they're asking you to use sigma notation, which is in the blue on the left. Also be careful that you know they're actually talking about a series problem. This one pretty much shows it by your multiple choice answers, right? Because you only use sigma or this formula when it is a series. If you go back to the one on the first page, this one didn't actually tell you to use a series, right? You had to figure it out by what the problem was talking about. And we talked about earlier in this video, we knew it was a series because we're talking about having to add all of these pieces up together to see if it gets to less than 40 feet. So keep in mind, if the problem's talking about adding all of your terms up together, it doesn't have to come out and say use sigma notation. You have to infer that that's what it wants. And that's all for this video.